All right, ladies and gentlemen, so today we're going to take a look at graphing inequalities, both a plane inequality and a systems of inequalities. The first step, because we're going to do this using whether you do it on a calculator or whether you do it by hand, our first step still has to be graphing the line, which means it has to be in y equals mx plus b form. You have to get it into y equals mx plus b. Now, if you remember, when we did solving our inequalities and we would graph them on a number line, we would have open and closed circles. On a coordinate plane, you're going to have solid lines or dotted lines. Solid lines are going to be the or equals. Dotted lines are going to just be the greater than or less than. And you'll see examples of that. Once it's graphed, then you have to use a test point. 0, 0 if possible. To check to see where to shade. To check shading. Right, and when we did them on a number line, we went, right, you either shade to the left, to the right, or sometimes it was in between, or to the outsides, depending on the situation. Step 3, you're going to actually do that shading. So we're going to practice on just one equation or inequality at a time, and then we'll get into the systems. So for number 1, I don't have y by itself, so I have to divide everything by 3. So that's going to give me y is greater than or equal to 2/3 x minus 1. I'm going to do this by hand, right? So we have our slope is 2/3, our y-intercept is 0, -1, and this, because it has the or equal to, it's going to be a solid line. So I'm going to start graphing it just like I normally would. I'm going to start at 0, -1. I'm going to go up 2/3. I'm going to put as many dots on here as I possibly can to make my line nice and straight. If you're doing this on paper, I expect you to use a straight edge. It's a solid line, so I'm just going to connect it like normal. But now what I have to do is I have to figure out, am I going to shade above the line or below the line? And that's where this test point comes in. And you can pick 0, 0 as long as it doesn't go through the origin. So as long as your line doesn't go through the origin, you can pick that. And what I'm going to do is I'm going to put 0, 0 in for x and y. So I'm going to have 3 times 0 greater than 2 times 0 minus 3. So this is 0 greater than 0 minus 3. This is a true statement, which means 0, 0 is one of my answers. So I want to shade towards that. So my shading, and you just do it with straight lines, so we shade it like this. Because I want to shade and make sure that 0, 0 is part of that solution. You should, of course, label your line. So 3y greater than or equal to 2x minus 3. All right, let's try another one. Just a plain one. Okay, so here I have to get y by itself. So the first thing I have to do is subtract 4x. So negative 3y greater than negative 4x plus 6. I have to divide by a negative 3. And when I divide by a negative 3, I have to flip the symbol. Switch symbol. Hopefully you remember that from our inequalities chapter. So y less than or equal to 4/3 x minus 2. My slope is 4/3. My y-intercept is 0, -2. And this is going to be a dotted line because it doesn't have the or equal to. So I'm going to start by putting my points down. We start at -2. We're going to go up 4/3. And again, we're going to put as many as we can. But when I connect them, I'm not going to connect them with the solid line. I'm going to connect them with a dashed or a dotted line. Okay, I still have to do that test point, and I can pick 0, 0 because it does not go through the origin. And when you're doing your test point, you always want to put it back into your original equation. So 0 minus 0 greater than 6, 0 greater than 6, that is false. 0 is not greater than 6. That means I don't want 0, 0 to be one of my answers, which means my shading is going to come down below the line. And then we're going to label it. Okay, to do a system, it's the same idea, except now you're going to have 2 on 1, and where those shadings intersect, you can see that up here, you label it with this great big S, which stands for solution set. So mark the solution set with an X, which is where the shading crosses. All right, so let's try these. So I'm going to start with this first equation here. It's already in y equals form. So m is 1, b is 0, 1, and it's going to be a dotted line. So I'm going to start by graphing that. So we're going to start at 0, 1. We're going to go up 1 over 1. And I have to make sure it's a dotted line. I have to do my test point. And I can test 0, 0. So 0 is less than 0 plus 1. That is a true statement, which means I want to shade towards the 0. So my shading is going to go down here. And this was y less than x plus 1. All right, now I'm going to do my other equation. I'm going to copy the whole thing over just so that I have some space here. So I have to get y by itself. I'm going to subtract 3x. 4y is greater than or equal to negative 3x plus 12. Divide by 4. I'm not dividing by a negative, so I don't have to worry about flipping that sign. So my slope is negative 3/4. My y-intercept is 0, 3. This is going to be a solid line. So I start at 3, and I'm going to go down 3 over 4. Okay, solid line. I have to do my test point. And again, I can test 0, 0. So that's going to be 0 plus 0 greater than or equal to 12. 0 greater than or equal to 12, that's false. Which means I don't want to shade the 0, 0, I want to shade away. And where your blue and green, for this case, overlap is where our big S goes for the solution. Okay, let's try. I think we have one more. Oh, which of the following coordinates are included in the solution? So we have y is less than x, and x plus y is greater than or equal to 5. That's supposed to be an x. Okay, so if I look at them, I can automatically rule this one out because here y is bigger than x. All right, so that part I can automatically rule out. So these three fit into this, into that equation, but I have to see the other ones. Which one, when I do it, when I add them, are they greater than or equal to 5? When I add these, I get 3. That's not greater than or equal to 5. When I add these, I get 6, which is greater than or equal to 5. And when I add these, I get 6. So this one had 2 answers, which was fine. Okay? I think that might be it for examples. Oh, look at that, blank page, we're almost done. Any questions? You guys know what to do. Bring them to class, and have a good night, guys.